Hey Bridgies, this is a quick video going through, well, probably won't be that quick, going through the 5 homework problems that you have today. Now, note your problems will probably be different because they auto generate questions, but this will give you a good idea of how to start. So this first one, determine a quadratic function. So let's remind ourselves what quadratic means. It means something with a power of 2, so an x squared of the form, and then they give us this form. This is in vertex form. We really like vertex form because it clearly will tell us the directions the graph has been moved. So as a reminder, if there's a number on the inside being added or subtracted, that shifts our graph right or left the opposite direction. And if there's a number on the outside, that shifts our graph up or down the same direction, right? So we'll talk a little bit more about that. So a normal quadratic function starts at the origin, okay, and then it is facing up and looks something like this, all right? This is something we spent a lot of time talking about in previous units, but also has been mentioned in this unit. You kind of have to know your functions that we've talked about throughout the class this year. All right, so we got a quadratic function that normally starts at 0, 0. Well, what's happened to this graph? This graph, if you notice in my picture, has been moved to the right 1 unit. So then we have to kind of figure out, all right, if it has been moved to the right 1 unit, but hasn't moved up or down, where do I put that number? Well, that number is going to go on the inside because it is right or left. So my function f of x is going to have something with a 1 on the inside. Now, if it goes to the right, right numbers are normally positive, but when they're on the inside, we have to do the opposite. So it's actually going to be a -1. A -1 is going to move things to the right. Now, you might be wondering about this A in front. Not very often will that A change from being 1, but something to look at is that our first points off the vertex are up 1 over 1, and they're the same in that other graph. So that's not going to change. So our function in vertex form is actually x minus 1 squared. There is not going to be a k value because this didn't get shifted up or down at all. Here's our next graph. The graph is a translation of this function, f of x equals the cube root of x. And cube roots were mentioned or introduced back in 10.2. So if you're like, what the heck is a cube root? Go back and look at that unit. So this is the starting of our function, but we may have to shift things right or left, or we might have to shift things up or down. So these h's and k's on the inside and outside are the same as what they were up above. A normal cube root function looks something like this. Okay, it's like an S curve. So what we need to do is figure out what happened to this graph. Well, if our our center of our graph is normally at 0, 0, this graph got moved what looks like to the right 8 units. So it's going right 8 units. Sorry, I spelled that weird. So we have to think about which variable is representing right. Right or left is going to be our inside, and it's always the opposite. So again, if I'm moving to the right, it's not going to be a +8 because we have to make it the opposite. All right, so it would be a -8. And again, we're not going to have that adding or subtracting on the outside because this graph doesn't look like it went up or down at all. Third question, this is a V-shaped graph. The V-shaped graph has an equation that is an absolute value. So let's think about this. The absolute value could have a shift right or left, or it could have a shift up or down. This one, a normal V-shaped graph, just like a parabola, starts, sorry, that's not very connected, starts at 0, 0, or the origin. So what happened for us to get to this other graph? Well, to me, it looks like it went from 0 all the way to -6, so it was shifted left 6. Okay, well, left and right is going to be that inside number again. And I need to remember to do the opposite. So if it's going in the negative direction, I actually need this to be a positive 6. All right, and once again, we're not going to have that k value because we don't have a shift up or down. Okay. Write an equation for the function whose graph is shown to the right. The graph shows a transformation of a common function. All right, so this is testing you a little bit more because they're not telling you what function this is. So you need to be able to look at a graph and be able to tell what kind of function they're talking about. This is one that starts at a point and then shoots off in one direction. This is our square root, oopsies, of x function. The square root of x was introduced in section 10.1. So if you're like, what is a square root? Maybe go back and look at that unit. So we're expecting you to know what this looks like. Just a quick comment right here. Down here, if you see this, don't get confuzzled by this or confused. This is just telling you what your window is. So our window on this screen, like my graphing calculator, my x's go start at -2. So this is -2, and it goes all the way to 18. And this is representing what they're counting by. So this is -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So they're counting by ones. On the Y, so this represents your Y window. It starts at, oopsies, -1, or sorry, -2, and then it is going up to 10. And it says it's counting by 1. So let's check -2, -1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I think that this should be -1 because I feel like there's not, anyways, it doesn't really matter. Don't let that confuzzle you because it doesn't really imply much or change things much. So anyways, what you want to know is that your square root function normally starts at 0, 0. All right, and then it shoots off in that direction. So what has happened? Oopsies. From 0, 0 to get to this function, well, it has been shifted over 1, 2, 3, 4, 5, 6. Oh, and now I can't see because I got writing in my way. Let's get out all those writing out. So let's try this again. 0, and then it shifted over 1, 2, 3, 4, 5, 6, 7, 8. All right, so it shifted to the right 8. All right, so our square root function, if I wrote it with the h's and the k's, h on the inside, k on the outside, if it shifts to the right, I have to go opposite. So it would be -8 instead. All right, so the big thing here is knowing what this looks like, this graph, so that you know what function to use. I believe this is the last question, and I think this is the trickiest one of all of them. They are giving you this function that they want you to graph. Now, fun fact, we have actually graphed this before, way back in topic 6, I believe, when we studied exponential functions. But the way that we want to stress again to graph this is to think about first what that parent function would look like. Parent functions are where we remove all of the adding and subtracting. So I'm going to kind of forget about the +2 and I'm going to forget about the -1. So my parent function is 3 to the x. My recommendation is to just create a quick table of values. So I like to do a little bit of positive, a little bit of negative, but if I plugged in a -1 here, I would get 3 to the -1. You can use your calculator if you would like to, but that gives us 0.333333333. Then if I plugged in a 0, 3 to the 0 power, well, anything to the 0 power is 1. If I plugged in a 1, 3 to the first is 3. If I plugged in a 2, 3 to the second is 9. This ends up giving us an exponential curve. This is an exponential function. And let's plot these points. -1 up a third, 0, 1, 1, 3, and 2, 9. These are the functions that have an asymptote because it flattens out. And since this is my parent function, it's flattening out along the x-axis because I haven't shifted it up or down at all. Okay, so this is my parent function. Now what we want to do is we want to reconsider the plus 2 and the minus 1 and what those are telling us. Now the plus 2 is kind of like on the inside, so we do the opposite. So since it's adding 2, that actually means it's shifting our graph to the left 2. The minus 1 is on the outside. It's not in the exponent, so that is actually going to shift our graph down 1. So I'm going to take every single point. For instance, let's start with this one, and I am going to shift it left 2 and down 1. Okay, let's do that with the second point. This is at 1 right now. I'm going to move it to the left 2 and down 1. Let's do with the third point up here. I'm going to go left 2 and down 1. And then my last point way up here, I'm going to go left 2 and down 1. So I'm going to make all these the same color, I think, so it's easier to see. I have this red point, that red point, that red point, and this red point. Okay, now let's think about what's happening to the asymptote. The asymptote isn't going to change if I shift my graph left or right, if you just imagine your pencil kind of scrolling along the same line left or right. But if I were to move my line up or down, that's going to shift it. So when you see an exponential function being shifted up or down, that is going to change your asymptote that direction. So we're actually shifting this graph down 1. So my asymptote is now changing. All right. So that's our new curve that has been, the black one is representing the parent function and the red one is representing our shifted curve. Now they also ask us about domain and range. Remember, domain has to do with your x and range has to do with your y. Domain is dealing with the side to side. My arrows on this function are pointing to the right, or sorry, left, and then they're also pointing to the right. That is going to keep getting wider and wider and wider. So our domain, and in fact, your domain of all exponential functions are all real numbers. That's a little abbreviation there, by the way. You don't have to know this, but our range is talking about our y's, or in other words, how far up or how far down it could go. Our curve does not cross over this red asymptote. It doesn't go past it. It is above it though, so it could be anything up here because that arrow is pointing up. So the way that we represent this, and you learned a couple different ways, but one way to represent it is that our y values have to be greater than that asymptote. All right, they won't even ever equal it. So I'm not going to put a line underneath because they have to be greater than it. They never reach that. I hope that helped. Have a great